And we're live, I assume. Yeah. Is the voice really sensitive? Testing 1, 2, 3. It's so weird. 1, 2, 3. I got you. Yeah, to do. Yeah, I'm just practicing more linked lists. Something really dumb and easy linked lists, and just like figure out how it works properly. And I will not be afraid of like why would I need linked lists for these? But yeah, just do some simple tail checking. Oh, it means there's a new problem. Yeah, it's new. Find champion. And I don't like this already. It's graph traversal. Directed acyclical graph, isn't it? I think that's the acyclical means that it never like go back to where it's from. Yeah. A will be champion of the tournament if there's no team B that is stronger than team A. Directed edge from means team is stronger than team B and B is weaker than team, okay? Team 1 is weaker than 0, team 2 is weaker than 1, so the champion is 0. Yeah, I agree. Champion should be 0. Oh. Okay, because we don't know. Right. This is not a bad one, but oh fuck. Okay, we're back. Intersection of two linked lists. Of two singular lists AB, return the node at which the two lists intersects. If the linked list have no intersection at all, return null. Follow two links being intersected at node C1. Node at which, okay. I would have started at the end. Generally suggests there are no cycles anywhere in the entire linked list. Their original structure after the function returns. So custom judge. The inputs to the judge are given as follows. You're probably not given these. The link based on these and fill pass the two heads to your program. Essentially, it's figuring out when because I don't know these, but I know these at 8. What? At 8. Well, it shouldn't. 1, 2, 8. Yeah, why? Oh, because I chose the intersection value. Which two intersect? These are not intersection. References. I'm not completely certain I understood this. Two pointer. Head A. If one is none, else. That doesn't. If one is none, else. I'm not completely sure I. Okay, first the store. First set, cur is, well, cur, added to set, adding everything to set, height, and then it will be space on, cur, now cur is head, so while if cur in, return cur. A two pointer would not even. While hashes of two of the problem description state that both the input have the same tail. Both are merged at some point. It means that one in case. Oh, so it means. Because this I got confused about again. Why wouldn't one be correct? Note that it's not because the nodes with value 1 in A are different node references. In other words, they point to different locations in memory, while the nodes with the value 8 points to the same location in memory. Why? Please explain. Because even though both have nodes with value, the nodes are not the same actual node in memory, the same value. actual node in memory. That's why. Need to be stored in the same location, but they are. So where the two meet. I stole Tomt. Stan. This is confusing. But why? I don't fucking understand it. Is it because when we create list A first? Because this doesn't exist, but this exists. Okay. I think I might just look at this solution first. Is undefeated for a winner in edges. Champion count for team in range of n. Champion equals team. But still, order. By whether the node, not just the value, are the same in memory. A or B. So for I think I understand. It's still some bullshit things. I think it's weird. Okay, so equals head of A, B equals head of B. So while A not equals to B, A equals head of B if A is none, else 1. Oh, it iterates multiple times. If B is none, else B next. A. Their hashes will be the same. That's not weird. It goes in a forever loop. Still, I didn't quite understand linked list properly. I think I just need to... Oh, it's actually free.
Now let's learn about linked lists, which have a lot of overlap with arrays, but also a lot of differences. The first thing to know about linked lists is that they are made up of list nodes, or sometimes just called nodes for short. A list node is an object that encapsulates two things at a minimum. These are the value of the list node. It could be an integer, a character, it could be another object, it could be anything. Maybe in this case we have a 4 as the value. And also we have next, which is a pointer. This is going to tell us what is the next list node in the linked list. So this is essentially a way of connecting multiple list nodes together, which forms a linked list. If we just had a single list node, it wouldn't be very useful. In this case, let's say our next pointer points at null, which is another way of saying that it points at nothing. That means that in this case we just have a single list node. That's not very interesting, so now let's understand how these nodes can be connected together. Let's first build a linked list. So first I'm going to create one list node. The value I'm going to give it in this case is going to be a string. Let's call it red. And the next pointer is initially going to be empty, or we could say it's by default set to null, so it's not pointing at anything. That means this list node is not connected to anybody yet. And we know when we create this object, it's going to go somewhere in memory. We don't necessarily get to control where it is, but we know it's going to be somewhere. We know that we're going to have a red node somewhere in memory, and it's not going to be pointing at any other node yet. Next, we'll create a couple more nodes, let's say a blue node and a green node. So now that we have 3 list nodes, it's time to actually connect them together. Now in most languages, the next pointer is actually a reference to another list node. That's how it's implemented. So in terms of code, this is what we could do. We could set list node 1, assuming that's the name of our variable or object that we created, dot next, the next pointer, to be list node 2. So what that would do is take this pointer and basically tell it that the next node in the list is going to be this node. Now what's actually happening under the hood at the lowest level is we have some address for our second list node, our blue list node, let's call it XX, and maybe this one is stored at address YY. The way we know how to get to the second node is at the lowest level, maybe your language or operating system is doing this, the pointer tells it that that the address is here, so that's how we know how to get to the second node. But usually, depending on the language that you're using, you don't have to worry so much about the address because the reference to that object is enough. So when we talk about pointers, we're usually talking about references to objects. But I'm mentioning this because as you can see here, the nodes are out of order in the way that we're going to connect them. We've connected our red node to our blue node, but the order in actual memory is the opposite. What this means is that linked lists are not stored in memory the same way that we use them as programmers. They could be in some random order in memory, but they're connected via pointers. So the red node is going to point at the blue node, and eventually we're going to have the blue node point at the green node. We could have some big mess like this in memory, but as programmers, we're going to have something nice and clean like this. So this is a difference from a linked list compared to arrays. Arrays are stored the same way in memory, but linked lists, as we can see, are not necessarily stored the same in memory. Next, for us to connect list node 2 to list node 3, we would do the same thing we have down here, except for list node 2.next, we would have a 2 here, is going to be set to list node 3. So something like this. And then we would have a nice linked list finally formed like this. So now that we have an idea of how linked lists are stored in memory, we're not going to worry so much on the details of what's exactly going on under the hood. Now, what if we wanted to start at the beginning of our linked list and then loop through every single node until we got to the end? And we would know we got to the end, by the way, because our last pointer is not pointing at anything. Now, depending on the language that you're using, the code for that would look something like this, where first we have a variable called cur, we initialize it to be at the first node in the linked list. And we keep looping as long as our pointer current is not pointing at null. What that means is we have a valid linked list node. So let's walk through this code really quickly. Suppose this is our current pointer, it's pointing at the red node. That's how it's initialized. Then we go to the while loop statement. Right now it's not pointing at null, so then we're going to enter the while loop. Current is going to be set to next. So we're going to follow our next pointer over here, which is now going to be pointing at the next node. Very simple. Then we're going to go back to our conditional. Current is still not equal to null, so now let's set it to current.next. So we're going to follow the next pointer, which is now pointing at the green node. So this is where our current pointer is now going to be. We're going to again check the condition. It's still not equal to null, so now we're going to follow the next pointer again, which in this case, it is pointing at null. It's not pointing at any other node, so now our current pointer is going to be set to null, and then we're going to execute the conditional, and in this case, it's going to be false, so we're going to no longer execute the while loop, and we're done with that piece of code. Now, my question for you is what would have happened instead if this next pointer of the third node was actually pointing at the first node? Well, we would have started here, then went to the blue node, then went to the green node, and then we would have came back to the red node, and then back to the blue node, back to the green node, and just kept doing that over and over again. It wouldn't be very fun to run because the program would crash. It's an infinite loop. But going back to the first case where we didn't have an infinite loop, what was the time complexity of going through the entire linked list? Well, it was the same as doing so with an array. It was big O of n, where n is the size of our linked list. So far, we've learned that linked lists are pretty similar to arrays. Let's talk about a few more similarities real quick. As programmers, it would probably be helpful if, as part of our implementation of the linked list, we're always keeping track of the head
3
of the
people
linked
are
list,
watching me.
the tail of the linked list, and the end of it. So let's assume that we always have pointers that can give us access to the first element and the last element. If we have a linked list of size 1, suppose these didn't even exist, that means our tail pointer would be pointing at the same.
Yeah, it looks like it's why is it?
But in this case, we have a couple more nodes. Suppose we now wanted to add.
Yeah, what up? Hey, you can probably hear me. Why is this not properly connected anymore? I don't have TTS, but like your message is not shown either. Event not started? It what? I don't understand what the fuck is the issue. Like at least I would like to have some alerts. With my like I don't care for the TTS, but I want alerts. Yeah, because like my little lab sent message yesterday. I don't know why the fuck it's not connected properly. Weird. Then I can't log out and log in with this solid. Yeah. It's so fucking slow, it annoys me. Please, there, okay. What? Am I a robot? Oh, yeah. Speed run the captcha. Let's say these two. Yeah, this is the old one. Okay, the Leetcode way might just not work. At least in Leetcode. But it's so fucking annoying. Why is it not? I don't need this right now. In chat, just do some. Okay, what is it called? Chat settings. This is even on. Is this the issue? Let's turn it on and off. Wasn't it affected? Turn mode on off to reset the connection. It was probably because the relay not working properly, and what the fuck? I don't understand. Well, not okay. I checked to check it seems something is increasing, sometimes decreasing. Okay. Well, or not monotonous. Trick is that binary search is a bit like Dijkstra in that aspect. You can have a faulty implementation still give you correct results. Yeah, but totally. No, I had like 3 or 4 viewers. That was new record or something. No. But still, this is. It looks like it's working fine, so it's probably the relay mode being fucked up. I can filter. Oh! I can filter shit. Nice. Yeah, back to what I was supposed to do. The bot. It's on or not. Test? Nope. This is the confusing thing. Okay, if I just do this, no. Because apparently I am live. Am I not? I'm pretty sure I'm live. I am live. See? Weird. I kind of want to fix this just like... Yeah, but it's not the TTS bot that's the issue. I don't get alerts. So I have no idea if people are typing or not. not that it's important, it's just like I like to be able to talk to people when people talk to me. I might do it at the end of the stream then, because it says I'm streaming on both. Who fucking knows? But like I said, it's not an issue with, because now I need to tab in and out of this chat. Or can I do it here? I can also go in here, and then I can switch between them. Probably gonna be so fucking weird. Do I have chat? Maybe I actually should might actually just have it in chat. I would assume this would be a browser chat. Oh wait, I have chat? Oh, I have chat, never mind. It's just so fucking small. I completely forgot I had that. Okay. Weird. Yeah, you were saying they're using... Yeah, but I noticed it would be a problem with the check. After checking it further, like, oh, this is difficult to understand now, but like, I think it would be like, for 1, 2, 3, 4, it would be like false, 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 true, false. The way it was implemented. So I think that's like the issue why it did not work. The check was faulty, essentially. So I'm not certain, like, how I would change yeah, how I would change it. Oh, here earlier returns. I don't know about this invariance. The only important thing, he doesn't explain it in his video. Yeah. I didn't see the video, to be fair, so I have no idea what he says in his video. He doesn't explain why check is monotonous or whether it's increasing or decreasing. No. So essentially, out of curiosity, like, what do people say? Okay, I'll kind of want to keep it. Eric Doe, I will keep him too, just because I was searching for that. What is it called? What is the task called again? Like minimum median of 2 sorted lists or something. Like, what do people say in the comments? See, I don't know if you're talking to me. Yeah, you're talking. Yeah, like I just want to see like what other people say about it. Also, it's yeah, I agree. I was thinking the same thing. Which one? Like, see, now I have no idea how to. Control F. How? Okay. Help me understand. In this one, we are searching for the correct partition in an array such that number of in the merged array is all the elements in the left of both the arrays are lesser than or equal to all the elements in the right partition of both the arrays. If A left is greater than B right, shrink the partition. Shrink the partition. If B left is greater than A right, increase the partition. Yeah, obviously he doesn't answer it. This is where yeah, I hope I never get like this question in the interview. Okay, this might be interesting. Okay. Okay, cool. Well, no, but everyone always talks about the details of the process, but that's not important. If I get this question, I definitely go for my solution, easy to prove. While he's using a trick, I don't know about that. I need to rewatch your solution. I think I kind of understood it, since I think I understood it. Essentially, it's taking... Yeah. No, I agree with you. But do you have the link to your own submission? I want to look at it again. Because I think I understood it. I just want to confirm with you. Thank you. Because this is the binary search for the first and this is for the second. So they are basically identical without like these changed. So this is essentially your check. Okay, this is a dumb question probably for you, Solaris. I always get slightly confused about the or and. Would this mean that either this is correct or this is correct? Or is it either this or this is correct and this has to be correct regardless? I just don't remember like the syntax or what it's called. Or it's like, okay, and is, okay, then that makes sense. So and would be, so this has to be correct or this has to be correct. Yeah, perfect. Because I knew there was like a rule for it, I just didn't remember. But it might be like a sidetrack, but like if I, for instance, wanted to have like either this is like this is correct regardless, but either this or this can be correct. Would just parentheses work to do that, or would I need to write? How would it be? This and this, or this and this. If I don't capture that element, then I don't capture enough, and I need to be bigger to capture it. If I do capture it, then try to be lower. Oh yeah, I'm still like on the precedence rule. And check whether to do capture in the other increasing Boolean function now. Once I capture some things, if I'm bigger, I capture at least as much. No, if I, for instance, can I just write it somewhere? Like for this, now this is basically the same as this. However, if I wanted to be like this, would I need, would this work, or would I need to write it like and or this? My question is essentially, is the parenthesis, is it following a normal rules that parentheses are the most important? In PEMDAS, I think it's called in English. Yeah. Okay, cool. I just need to confirm it, just because like it's something so elementary that I should know. However, I was uncertain. But cool. If I don't capture that element, then I don't capture enough. I need to be bigger to capture it. If I do capture it, then I try to be lower. So my check is increasing Boolean function there. Once I capture some things, I'm bigger and I capture at least as much, yeah. Which is a better check, to be fair. But I just need to decipher this correctly. This is for nums1. Lim is the limit, I would assume it's shortened for. -2 minus mid greater than 0. Less than 0. Or if it's greater or equal to m minus 1. And the num of 2 of the same position is less or equal to, yeah, okay, so I understand your logic, I think. I just don't understand exactly, like, if in my mind, like, how would I write this? Because, like, this section is pretty simple to understand. This is, like, great. I think I would like to try to draw it, and like I said, then the thing is I also need to check for target of lim and for target of lim, the even case. Okay, let's just start here. How would this, like I said, just to completely understand how it worked, can I just do some giant, no, let's just create a new one. And this, can I make it smaller? I don't need. Okay, that's too small. Maybe 26 looks good. Yeah, oh my god. Great. So for the example of, I like brush, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. This is nums1. And this is nums2. 7, 8. So we're checking for nums1. Low is -1. I'm doing like really slowly. I hope you don't mind. It's just like for me to do without it for even case. It's the easiest way to write it for me. Okay. And then okay. I hope you don't mind like me actually going through every iteration. Now still nothing weird. The iteration just to like completely ensure I understood it. So this is an odd case, so it will take the minimum of those. So okay, essentially -1, I don't know how to write it best. So -1 and high is equal to n, which is length, and so this. So it should return mid is 2. And if, oh, no, when I had to start at the limit. Okay, for 0, like f1 of 0 Just ensure like I completely understand it. Yeah, right. So 0 minus 2, and we know mid is 2, so if the 0 is not less than 0, and this is would be 8, 7. Well, it's minus 2 minus mid, never mind, it's minus 4. Which is, to be fair, less, so high would become mid, so high is now... High is now 2. Yeah, and then it continues again. Now mid would be 1, right? So limit 0 minus 2 is minus 3. So then this becomes 1. And then 2, it's still 1 again. And now the... Or would it be 0 now? At least low does... Okay, high is... I got confused. My brain not working properly. I think this is the only thing that I'm not certain about, like... I would never be able to understand that this is a check. I understand you're looking for something that is... you want to find the size you need to be able to retrieve all the elements in... Can you just take your code and just run it and see what happens? Because I realized like the iterative way was way too slow. Okay, so we have this. And I would like to print out F2 of lim. Oh no, lim is not, it's inside here, which I'll create my own test case. So 8. So this should return 4. This is odd. If... Well, this is for the odd one. No, what? N plus M modulo. It would return... Yeah, okay, no, it's for this one. Okay. Yeah, you even have this. Great. Oh, nums. Oh, fuck it, I just copied this too. Yeah, sure, call me on Discord. Hello, what up?
Yeah, so, oh, I have an info. Okay, so I can maybe draw the thing.
Okay, so I should, yeah, sorry, I started sharing. I will stop sharing.
Okay, So we have N1 N2 and the check is basically for each index in element. So this element captures those elements. Okay. Let's say the target, so the number of elements I must capture, the limit, is 3. Then I must capture one more. So I just get the index that corresponds to, so where the index is 0 index, so like it's 0, 1, 2, 3. So the index is 1, and I need index 0 when the target is 3. So that's why the -2, because the formula is 3 minus 2, actually minus 1. So there it would be 0.
Yeah.
So that's the index I need to
Yeah, because
in the overarray very minimum. And then yeah, is it captured? Like, is it inferior or equal to that? That's the check. If it's captured, then I say I capture enough, and I try to take a lower index, a lower value. And if it's not captured, then I try to get a higher value, because the function is increasing. So
how do you know if you capture the element?
if it's okay, then I shrink the right bound shifts and. Oh yeah, capturing just means that this has to be greater than this.
Okay.
Say this is V.
V is great. Okay.
This is U. No, this is X. V. Yeah.
Okay.
That means it's captured, and because it's sorted, if you capture it, you capture everything to the left of it. So
yeah.
You capture enough elements that you want to capture, and if you don't, conversely, if you don't capture it, then you are missing. You only capture that. You do not capture everything there, so you do not capture enough, and you need to take a bigger one. Yeah.
Okay, so can you do an example with limit 4?
Okay, limit 4. So limit 4, we can see usually that we need to see index 1, and of course, because it's for -2, -1, it will be 1.
Yeah.
So we're looking at that element. Compared to any element where this will be variable during your binary, but the check is for a given index, for a given index. In our case, it was this. We're currently treating that one, checking that one. So now we just compare 1 plus 2.
Okay,
See which one is bigger. To see if the red captures the orange.
Because the way you explain it seems better than what Leetcode had.
Yeah, but if what Leetcode had actually works, which it didn't prove, and in his code it's an early return, so I don't know. Well, it would be slightly better in terms of time complexity, particularly in the case where you have, like, let's say, a very small array.
Yeah.
A very big array.
No, and now I understand, because
the only runs on the small one.
No, because it would be.
It doesn't matter, because logarithm actually doesn't grow very quickly. So
Exactly.
When you have a log solution, if it's log or log times log,
Yeah.
log times log, it starts to become a bit more troublesome. But let's say in problem you can have array of up to 10 to the 6 elements. So the approximation is that 10 to the 3 is about 2 to the 10.
Yeah. I remember.
10 to the 6 is about 2 to the 20.
20. Yeah.
So you have 20 iterations.
Yeah.
Which is not much usually. So if you do it twice, you have twice something which does 20 times the number of operations. Well, you do really a neglectable number of operations.
Okay.
That's why it takes 0 milliseconds.
Yeah, fair. Okay. Thanks for the explanation. The only issue I have would be that I would never be able to, like, even though I know that's the way I would solve it, I would never figure out a check that would work for me.
Yeah, but you notice that yesterday, well, yeah, I wrote a message, yesterday in the morning. This is the best I could come up with, and it was a log n by log m solution. So it's not until having thought about the problem like today,
Yeah.
for quite a bit, I found a solution. Like I just thought about the problem in the background that I found this idea. But it's actually hard, because even if I had this problem, like let's say in a contest, I would
Yeah.
not have found the solution.
Okay. Yeah, I was going to say like this.
Actually, it's one of the like hardest problem.
Really? Okay. But yeah, I see.
For me, at least, because
No, but a lot of people also said that.
deemed hard. Yeah.
Yeah, because a lot of people said it.
Problems, they are hard because you just need to know a technique.
Yeah, exactly. Yeah. Because remember, like the way I'm thinking is more in the realms of how would I do it on an interview, while you are probably looking more into how would I do this in competitive programming.
Oh yes.
And in both cases, this is
use like meaningful variable name. But I think there is a strong overlap.
Yeah, no, I agree. I remember we talked about it a few days ago. It's like there's definitely an overlap. But the main difference, I think, is in
You see, if I was an interviewer and someone would come up with Leetcode solution, I would ask them to prove it, not really formally, but binary search work. If you have a monotonous check, and there, if I don't see how it is monotonous, then I will ask to prove that it works with this principle, or to prove that by chance it works with another principle. That's like side of binary search, but then I would have to also see that.
Yeah. No, I agree. I think that. I think the biggest difference is like in competitive programming, it's more you need to get an optimal solution, while in interviews you can probably use other skills that might you might get not get the right implementation or right answer, but as long as you went through your thought process and the interviewer sees like, oh, this guy actually knows what he's doing, I think you will score highly there. While in competitive programming, they don't give a shit about that.
Yeah. Also, will you try to solve the question 4 and question 3 of the contest?
Question 4 and 3?
Question 3 and 4 of the weekly.
Of the weekly, I can look at them, but because like I think I understood like I had an implementation on question 3. Yeah, why is my...
Oh, yeah.
It's so slow now.
Was it greedy or... Because I brought my tooth on greedy. It didn't work.
What is...
I wrong submission trying something greedy.
Yeah, because like What's wrong with... Dude, you're cutting out all the time. I barely can hear what you're saying. I don't understand what's wrong.
Oh, sorry. No, maybe it's because I don't know. Well, if you want to say something or not, but like I was saying, in those problems where you can divide or you can subtract,
Mm-hmm.
there are some of those problems on like forces, and it's often greedy, and often the trick is like it's always better to divide first, because if you subtract and then you divide, you divide your subtract.
Yeah, I was
So
thinking
it's
this.
like you have subtracted less.
Yeah. No, I was thinking it's like it's always better to do this first. However, there were cases where that wasn't necessarily the best thing,
Yeah,
and that was what stumped me. So I,
yeah. So that was tricky.
so I tried to do some backtracking to figure it out, but I ultimately I didn't have enough time to finish. I think backtracking might have worked because like for my initial, I was doing like, oh, first you do all of these and then you do all of these, like a really simple way of doing it. But then I realized, oh, yeah, it's not always correct this way. So I tried backtracking. I was just unable to create it. Simply, it wasn't. But I think it was a backtracking answer. That would be the correct answer.
What do you mean by well
Uh,
recursion? You mean
yeah, recursion, essentially. Like
yeah,
recursively.
but you don't forget to memorize your yeah.
But
You need memorization.
yeah.
If you do not know if you do not know whether you need memorization or not, always do memorization.
Okay, I will actually write it down, just as a good tip. Uh,
Yeah. It will be slower, but not by much, and it will pass when well, you know, if you have overlapping computations and you don't memorize, your solution is just doomed to fail.
yeah, yeah. So I see it now. But regardless, I'm not that familiar with like recursive and backtracking and all of those. I need more time to
Oh,
like.
I think you have the right solution. I did something similar.
So what I ended up was I just searched everywhere because I knew it was gonna be something along these things, but I just couldn't figure out like exactly what to put. Like I thought this would be correct, but it just never returned correct.
It isn't.
No, it didn't work.
It it didn't return correctly. Well, was it too slow or was it incorrect?
Incorrect. So I knew it was something here. I did something I did wrong here. See, I'm I'm off by 3 in both cases.
Just returning the. What? Are you just returning the initial sum? No. Uh, you return the sum when you are at the end. Okay, you start with infinity, which is okay. Minimum, you want the minimum, yes. Okay, you can just keep right away and not use any operation. You can use one operation. Oh, I see what you. Okay, you missed a case. You missed one. There are 4 cases. There are 4 cases.
There are 4 cases. Is the last case?
SM is not updated the same way whether you use one operation. You update your value, but you update it always in the same way. When you use one operation, well, it's not because you used it on the current element. So the current element that you have now it's divided by 2.
But I just noticed something like out of curiosity. Minus k.
Oh, you also, I see you're trying to modify nums in place, and then you do some nums. Yeah, that would also work maybe. OP2 are not commutative. They are not commutative. So if you do OP2, OP1, it's not the same as OP1, OP2.
Yeah. That's true. That is true. There are 4 cases. Oh. So essentially, how would I write it then?
We just add the missing case.
Yeah, but why did I do this? Why do I have 2 here? And 2 here. Oh, because it has to be more than... No, what?
No, I don't know where you have to.
Yeah, yeah, why do that? Okay, if this works... I just wanted to check, like... It should be
It
0.
will probably not work because, like I said, yeah, like there are...
Yeah, but I just want to see like it works on it fucking works on this. I just want to see like it works on some cases, not all cases, just like some cases it will work.
Yeah.
Fuck, was that my issue that I'd mistyped 2 and then copied it over here? Oh my fucking god, if that's the issue. Yeah, like I didn't expect it to work like the... But how would I write the last case? Would it be like... Wouldn't it be exactly the same as this?
The conditions for using...
I realized it's probably easier for you to...
the same as the last...
Yeah, it's the same. Would it, like, the...
It is the same as the last case. You just swap the OP1 and OP2.
And essentially it's taking this
What
and
do you
just... Yeah, that doesn't matter. I realized what you meant after doing it. So instead of doing...
Yeah,
it would
okay.
be... OP2
Also,
of...
you're not making it easy for you because you're modifying nums regardless of whether it's the best way to modify it. So there nums will always be modified with the last yes. I don't know why you modify it. Okay, so function whenever you modify nums. I think the best way is to return the result of the function. There it seems like you were trying to do both at the same time.
Okay, I'm happy that it actually did some... Because I assumed this was the issue.
No, okay, it's 1. -1 expected 0. Oh, why do you have to go back?
I need to check back in. Yeah.
So you initialize sum as a sum of the initial num, and then
I can just send you this. Another problem. Pardon me. Just like.
you're not far. Well, you're not far from the solution. You can see. I don't know if you saw what I did. Like the same as what you did. But I only have 3 arguments.
This is at least my submission, if you see, but I didn't pay that much attention.
Yeah, I saw it on the screen.
This is so trippy.
I need to leave you. So goodbye.
Yeah,
See you next time.
see you next time. Bye. Yeah, back to... I need to like be better at backtracking. Yeah, where did I left off? It still annoys me that I don't get notification. Not that people will watch that much, but still, if I zone out, I will just forget to check it for a while, which happened today when all the people were joining.
Add a new element to the end of the linked list. And let's say we create a new node and its value is purple. Well, if we want to insert it at the end conveniently, we have a tail pointer at the end of our current linked list, and all we need to do to add this to our linked list is just connect the pointer. So
Okay, well,
through the entire linked list. Well, it was the same as doing so with an array. It was big O of n, where n is the size of our linked list. So far, we've learned that linked lists are pretty similar to arrays. Let's talk about a few more similarities real quick. As programmers, it would probably be helpful if, as part of our implementation of the linked list, we're always keeping track of the head of the linked list and the tail of the linked list, or the end of it. So let's assume that we always have pointers that can give us access to the first element and the last element. If we have a linked list of size 1, suppose these didn't even exist, that means our tail pointer would be pointing at the same element as our head pointer. That's how we would know we only have a linked list of size 1. But in this case, we have a couple more nodes. Suppose we now wanted to add a new element to the end of the linked list. And let's say we create a new node and its value is purple. Well, if we want to insert it at the end conveniently, we have a tail pointer at the end of our current linked list, and all we need to do to add this to our linked list is just connect the pointer. So we would simply take the tail.next pointer and set it to list node 4, which is our purple node. So that would look something like taking this pointer and then instead connecting it to this one. But the problem here is that our tail is still pointing at the third node. We want to update our tail pointer now to actually be pointing at this one, and in terms of code, that's also pretty easy. We can set tail equal to list node 4. We could also have set tail equal to tail.next, because remember, tail is still pointing at the third node, and we know tail.next now is set to list node 4, so by setting tail equal to tail.next, we're automatically setting it to this node. Can you tell me the time complexity of this operation? Well, it was a constant time operation. Since we already had a tail pointer at the last node, we didn't have to iterate through every single element in the linked list. We started all the way at the end, and then we created a new node and then connected the pointers. It was just one operation that we needed to do, which is the exact same thing with an array. Now let's say instead we wanted to remove a node. Removing any node in a linked list, whether we're talking about the end of it or the beginning of it, is also always a constant time operation. But there's a really big caveat. That's assuming we have a pointer to the previous node that we're trying to remove. So if we're trying to remove this node, we should hopefully have a pointer to the previous node. So if we're removing this node, what we would do is set our head.next pointer. Instead of it pointing at the second node, we would set it to the next node that it's pointing to. So this is a little complicated because we're chaining the field. Head.next, remember, refers to this node. This node is equal to head.next. And then if we say .next one more time, we're following this pointer to the third node. So what we know is this evaluates to the third node. So when we say head.next, which is this pointer is pointing at the third node, we're basically getting rid of this guy and taking this and setting it to the third node. Now, if we want to, we can free the memory that this node was taking up, but in most languages we have garbage collection, so we don't really need to take care of that. The language and operating system will take care of that for us. We can assume that it no longer exists if there aren't any pointers pointing at it anymore. But this is sort of a benefit compared to arrays. We can remove any element from whether we're talking about the beginning or the end in constant time because we don't have to shift everything over like we did with an array. But in the general case, if we wanted to, let's say, delete an arbitrary element in the linked list, we would first have to start at the beginning of the linked list and then follow the pointers until we found the element and then remove it. So practically speaking, to remove an element, it can still take big O of n time if we have to search for the element.
Yeah, that was nice actually. Merge to sorted links lists. That seems easy enough. I've done it before, yeah. I might just want to try it out. I kind of saw something that I probably shouldn't see. Oh, I forgot already. I forgot what I was supposed to do now. Is the list not equal to each other? No, it's not. Does it matter which I start with? Fuck. Oh, it's a never mind. It's an empty list node and while list and okay, while both exist. Oh no, it was another question. So if it's less, node next equals to list 1. Yeah, pointing to the head and then it would move. Else it would move and node will be node next, so we're looking at next element, and then it continues until everything, and then node next is list 1 or list 2. What would this do? Sorry, I couldn't mute myself. I was supposed to mute. I hope no one got any ear damage. Okay, good. What is this doing exactly? I would assume one of these would be empty. No, no, you would just continue to the what's left of list 1 or left of list 2, because here, yeah, I see it now. Okay, that was a nice singly linked. Marvelous done. Oh, there's more. Is this different from... Oh no, just a short. Because I wasn't aware it was stored in a random order. That was something that fucked me up. If we point back to itself. Deleting, I also assuming that all I have a reference node. This is actually important. Yeah. Design linked design browser history. I don't like that. And queues. Haven't I done queues? No, I haven't done queues. Weird. Where are queues? Shouldn't it... We have stack. Linked list, and after that I can finally go to trees. I would assume this, yeah, that first, but first. Ooh. This is gonna be a fun one. And this is like prefix, isn't it? Yeah, prefix tree. Backtracking, which is the thing I need to learn. Now, how's the route again? I created a route. I think it's like going do, and then I think it was dung 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 dung. I think that's the way. It's math and geometry at the end. To there, he has a lot. How... I like this list more. Because then I've done basically all of them. Core skills. Quit code. Whoa! Damn, I didn't know he had machine learning. This shit I actually know. Nice. This I might actually check out. Courses. Okay, I'm really not feeling it right now. I might actually go to bed early. I just want to check if there's a point to stream any games. I haven't gotten the new DLC for Hearts of Iron, which is like one of my favorite games. I think, yeah, close to 1,000. How about Crusader Kings? So, oh fuck, I just remember in case people are watching, I hope not. Yeah, I was like hoping they're not watching. Yeah, so I like Crusader Kings 3. I promised myself not to start playing it until I'm done with Crusader Kings 2. And I'm pretty far away. Some of these are fucked up. How did I do this? Oh yeah, because I'm playing as the Lombards. Are there any fun games out? To be fair, I think I will end this stream early, once again, because I'm a little bit tired. So yeah, I will end the stream early. Might game some for once. I haven't gamed for a while, so yeah. Maybe I will stream again later. Who knows? But thanks for a short session today.